Hi students, in this lecture we are going to discuss about specific energy in open channel flow. So in many competitive examinations, questions are frequently coming from this topic, especially for civil engineering students. So let us discuss in detail about specific energy. So specific energy, students, we know that fluid flow is taking place in a channel. If we take or if we calculate the total head or total energy at different sections. So total head or total energy already we know this is sum of the pressure head plus diagram head plus kinetic head. Suppose if I draw a longitudinal section of a channel, so knowing that, so this is the bed of the channel. Here we have water surface. Above this we have the energy line, and we take this as the bed, this as the bed. So in this case, if we write or if you write the total energy, so total energy or total head denoted with H is equal to, so this is nothing but the head H, or sometimes you may represent this with Y also, and this is nothing but our velocity head V square by 2g, and this is nothing but the datum head is nothing but Z. So the total head or total energy we can able to write H plus V square by 2g plus Z. So this is what is the total head at any section. So supposing that, so in case of open channels, we know that the bed slope is very less. So when the bed slope is very less, we can able to take the bed of the channel as horizontal. So once we consider or once we assume the bed of the channel as horizontal, what will happen to the Z? So the Z value will become 0. The Z value will become 0. So for this condition, if we write the total head or total energy, so the C, that is nothing but able to write this as E is equal to H plus V square by 2g. This is nothing but the specific energy. So how to define specific energy now? So specific energy is nothing but the total energy per unit weight by taking the channel bottom as the datum. So total energy per unit weight by taking the channel bottom as the datum, so will give us the specific energy E is equal to H plus V square by 2g. So here H is nothing but, what is H? H is nothing but potential energy or potential head, and V square by 2g is nothing but our velocity head or kinetic head or velocity. Yes, sir. V is equal to H plus V square by 2g is our specific energy. Then what is specific energy curve? So what is specific energy curve? It's nothing but if we able to plot, if we plot the specific energy versus the depth of flow. Specific energy on x-axis I am taking, this is nothing but E. On y-axis I am taking the depth of flow H. So the plot drawn between the specific energy versus H gives us the specific energy curve. So already we have seen specific energy is nothing but E is equal to H plus V square by 2g, combination of H as well as kinetic head. So if we are able to divide this and try to plot, so we can able to write for E is equal to H. So E is directly or linearly proportional to the depth. So we can able to draw this as linear. Nothing but E is equal to H. We can able to write. The other one is for a given discharge. Students, in this case, for the value of E, we also can be written as, or this also can be written as E is equal to H plus, we know that Q is equal to AB, V is nothing but Q by A. So in the place of V, I can able to substitute Q square by 2G A square. Please keep this also in mind. Sometimes you may ask questions on this also. So E is equal to H plus Q square by 2G A square. So for this, for a given value, for if I am taking E as well as velocity head, for the given value of discharge, E is inversely proportional to the depth. E is inversely proportional to the square of depth. Why? Because A is nothing but dy. So E is inversely proportional to the square of y. If I go to plot this one, so how it comes? So this is nothing but, so it represents E k is equal to Q square by 2Z A square. Q square by 2Z A square. Supposing that if I am combining these two, potential as well as kinetic head, so to get the specific energy curve. So this is nothing but specific energy curve. So this is E is equal to, we have H plus Q square by 2Z A square. This is what is the specific energy curve. So students, on this specific energy curve, we are able to observe. So what is that? We are able to see here is, on this specific energy curve, on x-axis we have the specific energy. So on this specific energy curve, if I take this point, what this point represents? This point is nothing but the value of minimum specific energy. Yes sir, this is nothing but the minimum specific energy value. Right? So for this minimum specific energy value, if I am able to draw the horizontal and get the value of H, so whatever this is nothing but critical depth represented with HC. What is critical depth? So HC is called as critical depth. So for the minimum specific energy, whatever the depth we get, we call as critical depth. And the corresponding velocity or corresponding flow is called as critical flow. And please keep in mind, so if the depth of flow is above the critical depth, the given depth of flow is above the critical depth, we call that as subcritical flow. And if the depth of flow is below the critical depth, called as supercritical flow. One says supercritical flow. Please keep this in mind. So critical flow, subcritical, depends on, based on the critical depth. If the depth is above subcritical, depth is below supercritical. Please, you can able to recollect. Based on fluid number also we have differentiated the flow SR fluid number F4 or Fe is equal to 1. F4 is equal to 1. Critical flow. F4 is less than 1. Supercritical flow. F4 is greater than 1. Subcritical flow. So everything we have. Everything, I think the previous classification based on fluid number also we can able to recollect here. And one more important point what you have to remember based on this specific energy curve is nothing but for any value of specific energy other than E minimum, for any value of specific energy, supposing that I am taking here, so this is the specific energy I am taking. For this particular specific energy, we are able to draw a vertical line. It will come and cut the specific energy at two different points. And if you are able to get the corresponding depths. So this is one and this is another. So these two depths. So this one I am representing with H1 and this I am representing with H2. So this depths H1 H2 are called as alternate depths. Called as alternate depths. Right? So what is the point you have to remember here? For any specific energy other than minimum specific energy, there exist two different depths. These two depths are called as alternate depths. These two depths are called as alternate depths. So this one is about specific energy as well as specific energy. So the analysis for the analysis of flow in channel transitions, right? Channel transition in the sense whenever there is change in the width of the channel or whenever there is change in the bed slope of the channel, you can able to use this specific energy for analyzing the various irrigation structures like spillways or irrigation canals and etc. These are the applications of specific energy. Now, let us see a few questions which have been asked in competitive examinations on specific energy as well as specific energy curve. Yes. See this question. In Gate 2016. So for an open channel flow, the depth at which specific energy is minimum. The depth at which specific energy is minimum. So just now we have drawn the specific energy curve. Yes or no? So this one here we have, this is nothing but E is equal to P. This is nothing but E is equal to Q square by 2Z H square. And then here we have drawn this as the specific energy curve. So what is that they are asking? In an open channel, what is that they are asking? In an open channel, so the depth at which specific energy is minimum. So this is what is the specific energy E? This is the depth H. So specific energy is minimum. This is the point. So for the minimum specific energy, whatever the depth we get, just now we have discussed, E is nothing but, what is this? Critical depth. Critical depth. So what is the answer here? So answer here is critical depth. Answer here is okay. We get 216%. Right? Okay, next we have yes. This is JE 2020. So what is that they are asking? A rectangular channel carries a flow with velocity 3 meters per second and flow depth is 2 meters. Compute this specific direct question. Compute this specific energy. They have given velocity v is equal to 3 meters per second. Depth of flow h is equal to 2 meters. Asking specific energy, direct formula H is E is equal to H plus V square by 2Z. Yes or no? E is equal to H plus V square by 2Z. So this is nothing but directly substitute. This 2 plus V square by 2 into very simple problem. 9.81. 2 plus this 9 divided by so 19.6. Approximately this may come around 2.4 meters. Very simple problem. Direct substitution. Yes, the given data, direct form if we able to recollect, remember. So very simple, and we can able to solve this, right? So velocity given, depth given, simply we can calculate this specific, right? Okay. Next. Yes. So two depths corresponding to the same specific energy in a rectangular channel. Just now we shall discuss two depths corresponding to the same specific energy again. It's easy to draw. Let's see. Okay. Using this specific energy curve. We have E, we have H. So what is the depth they are asking? Two depths corresponding to the same specific energy. Just now we have drawn. This is nothing but some specific energy. I'm taking this specific energy. So whatever the depths we are going to get from here, here, we have represented this with here. This is H1, this is H2. I already told you H1 comma H2 are called as what? Alternate depths. Very simple direct question. So the answer here is alternate depths. B. Okay. Right. Is get to go at 14%. Okay. We have. The next question we have is what happens to the velocity head? What happens to the velocity head as the depth of flow in a rectangular channel decreases for a given specific energy? Already we have seen this. So we have the specific energy. Again I am drawing E. Here we have the H, but we have drawn this. So this represents E is equal to H potential energy, and this is our velocity head. E is equal to V square by 2Z or Q square by 2G A square. So here we have already drawn this one as our specific energy curve. So the question asked here is what is happening to the velocity head when the depth of flow decreases? When the depth of flow decreases, directly we can able to say when the depth of flow is decreasing, this is the depth is on y axis. When the depth of flow is decreasing, automatically the specific energy is increasing. If you wanted to take from the formula, how can we write this? So velocity, we know V is equal to Q by A. Velocity is Q by A. So for a given discharge, if we write this Q by B into Y. So for a given discharge, B already we know this is constant. We can able to relate V and Y as V is proportional to 1 by Y, that is inversely. So as depth increases, as the depth increases, what is happening to the velocity? As depth decreases, what is happening to velocity? So in the question they have given the depth decreases or the velocity head. So the depth of flow in the channel decreases. When the depth of flow in the channel is decreasing, automatically the velocity increases. Once velocity increases, what happens to V square by 2Z? V square by 2Z increases. Very simple, right? What is the correct option here? So it increases. So velocity head increases. Correct? The topic is specifically topic is very simple, at the same time most important. So I advise you to practice more number of questions in order to get in order to score some good marks in competitive examinations. Thank you. All the best.